Hello, everyone. Thank you for joining us. I'm Steve,
And I'm Scott.
and together we are Backyard Musings in the front yard because we got missionaries back in the backyard.
Still in the backyard.
Still in the backyard on their P Day. If you haven't noticed, we broadcast back to back. We record back to back, so we don't have to wake up at the crack of dawn.
Yeah.
So
we're gunning for a Ford.
Right, we're not
sponsored.
We don't sponsor Ford, but
they
hopefully
don't sponsor us either. So.
Yeah, hopefully they notice us. So we are the Science and Technology Channel, right?
Yes.
We're not the experts, right?
Right.
But we report what the experts write in scholarly articles.
Things that we find interesting and that we hope to be able to pass on and maybe help somebody or get somebody thinking, because it's got us thinking, that's for sure. So
yeah, yesterday,
like the last segment about the cancer cells.
Fascinating.
That is really cool. If they can jump on that and get that going, that would be life-changing, right?
It would be. It would be a breakthrough. All right. Water isn't just liquid, ice, or vapor. Under extreme conditions, it can transform into exotic phases, such as the newly observed plastic ice 7.
Okay.
This is strange. Okay, let's follow it. This hybrid phase, predicted years ago but only recently confirmed using cutting-edge neutron spectrometers, exhibits both solid-like structure and liquid-like molecular motion. Scientists published their research on February 12, 2025 in Nature. Would you like to know more?
In everyday life, we usually see water in one of three familiar states.
Yeah.
Solid would be ice, right?
Mm-hmm.
Liquid, we drink
water,
it, right? Or bathe in it, or wash, or whatever.
Yep.
Or gas, which would be like steam, right?
Steam, yeah.
Okay? So, however, under extreme conditions of high temperature and pressure, water can take on many other forms. Some so unusual that scientists call them exotic phases. Using advanced neutron spectrometers and specialized equipment at the Institut Langevin, that's got to be, I think we've talked about them before, right? In Sweden or
I don't know.
Norway or someplace. Anyway, researchers have now experimentally observed one of these elusive states for the first time, plastic ice 7.
I don't know why it's called. What happened to 6-5?
Yeah, what happened to 1 through 6?
Scientists first predicted the existence of plastic ice 7 over 15 years ago through molecular dynamics simulations. Quote, plastic phases are hybrid states that blend properties of both solids and liquids, end quote, explains Livia Eleonora Bove. I wonder if she's married to Emma Bove, the assistant attorney general.
I don't know. I don't know.
It's not a regular name. Our United States.
United States Assistant. Oh,
yeah, Emma Bove.
I didn't know.
That's not a common name, Bove.
It is not.
Do you think it's Cherokee? What do you think it is?
It is definitely not
Cree?
Cherokee.
Cree?
I would say it's probably more like French.
French.
Yeah.
Bove.
Bove, maybe.
Okay, all right. A research director at the the French National Center for Scientific Research.
There you
go. An associate professor at La Sapienza University in Rome, and an associated scientist at EPFL in Switzerland. Quote, in plastic ice, the water molecules form a rigid cubic lattice, like in ice 7, but they also rotate rapidly, similar to how molecules move in liquid water, end quote.
To study these rapid molecular motions, researchers use quasi-elastic neutron scattering.
Oh, that sounds impressive.
Yeah. A technique particularly suited for detecting both transitional and rotational dynamics. Quote, the ability of QENS to probe both the transitional and rotational dynamics is a unique advantage for the exploration of such exotic phase transitions compared to other spectroscopic techniques, says Maria Risigno. Okay, that must be where the Italian comes in, right? PhD student at Sapienza University and lead author of the study.
By varying temperature and pressure, the team identified 3 distinct states of water. Liquid water, where molecules move freely in both rotation and translation. Solid ice, where all movement is frozen. And plastic ice 7, an intermediate. Now, we're saying 7 because it's a VII.
So Roman numerals, right?
Right. I don't think it's plastic ice V.
Right.
Right, 7. But I don't know what this. We don't know.
Yeah.
All right, an intermediate phase where molecules maintain their rigid structure but continue to rotate. The experiments revealing plastic ice 7 were performed using the time of flight spectrometers IN5 and IN6 sharp at the ILL. That's that institute, Lau Langevin. Temperatures as high as 450 to 600 Kelvin and pressures from 0.1 to 0.6 gigapascals. That's up to 60,000 times the normal atmospheric pressure.
Now, how did you know that?
I've been in college.
Oh, okay.
The G's, giga, and PA's pascals.
Gotcha.
Were required to produce this exotic state of water.
The implementation of such demanding thermodynamic conditions in neutron spectroscopy was made possible by recent technology or technological advances achieved in collaboration between BOVE, CNRS Research Director Stefan Klotz, and ILL scientist Michael Merrick Koza as part of a long-term project at the ILL. Quote, the success of the study relies on the extensive expertise and unique infrastructure built over the years at the ILL, in particular in terms of complex sample environments and high pressures. That's according to Koza. Go on to quote with a quote. Additionally, the continuous improvement of ILL spectrometers, such as those made within the Endurance Upgrade Program, has facilitated even more sophisticated experiments carried out by state-of-the-art instruments.
A comprehensive analysis of the neutron scattering data also revealed that the molecular dynamics of plastic ice 7 could be more intricate than MD simulation had initially predicted. Quote, the QENS measurements suggested a different molecular rotation mechanism for plastic ice 7 than the free rotor behavior initially expected, explains Resignon. Additional MD simulations, together with Markov chain analysis, provided a more detailed picture of the water molecule dynamics. A four-fold rotational model, as typically observed in jump rotor plastic crystals, was identified as the most likely mechanism.
Further investigations, including neutron and X-ray diffraction measurements, respectively, on the D20 diffractometer,
okay,
diffractometer at the ILL and at the Institute of Mineralogy, Physics of Minerals and Cosmochemistry. Wow,
what?
I don't know. I have any idea what this is. Were carried out to explore the nature of phase transition from ice 7 to plastic ice 7. I wonder what the difference is. The transition is predicted to be either first order or continuous. This is a quote, by the way, depending on the simulation method used, explains Bove. The continuous transition scenario is very intriguing as it hints that the plastic phase could be the precursor of the elusive superionic phase, another hybrid exotic phase of water predicted at even higher temperatures and pressures, where hydrogen can diffuse freely through the oxygen crystalline structure.
I don't understand how that can happen.
Man, what gets these guys excited, I wonder? They're doing all this special stuff. I mean,
I just don't imagine how those hydrogen can move freely because they're connected to the oxygen.
Yeah, I just can't picture these guys being fishermen or hunters or anything like that. Or
no,
so they got to have something a lot more intense, probably, to get them.
Yeah, intelligentsia.
Yeah, I guess.
Yeah, so. Both plastic and superionic phases are of high interest in planetary science, with potential implications in our understanding of the internal structure and glacial flow of icy moons like Ganymede and Callisto. Here we're going to the explanation of the why. That's cool. And icy planets like Uranus and Neptune, where they might dominate. Neutron scattering hasn't traditionally been a go-to technique in planetary science. Nevertheless, its unique ability to precisely measure the location and dynamics of hydrogen in a material, combined with the recent possibility of conducting experiments at planetary relevant pressures, has enabled neutron scattering to make a substantial impact in this domain. And there may be more exotic phases yet to be uncovered. Oh, wowee, right?
Okay.
I think it's cool for the planetary stuff. I wonder why NASA's not
involved in it.
Yeah.
I don't know, but yeah, this kind of stuff obviously way over my head, but fascinating stuff. I mean, I would have liked to know what happened to maybe 1 through 6 were failures.
Maybe
this is the seventh time.
Yeah,
I don't know.
Yeah.
We'll see.
I just work here. You know what I'm saying?
Yeah, we just talk.
All right. Thanks, folks. Thanks for joining us. We'll catch you in the afternoon.
Yep. Take care, everyone. Thanks.